Bonjour, buddies. Welcome back to another video. Today's first question is, Boston is 295 miles from New York City along a certain route. A car starts from Boston at 1 p.m. and travels along the route towards New York at a steady rate of 50 miles per hour. Another car starts from New York at 1:30 p.m. and travels along this route towards Boston at a steady rate of 40 miles per hour. At what time for the cars to pass each other? Or do the cars pass each other? Sorry, grammar mistake. Anyway, so I've done a problem extremely similar to this in a previous video. And I said that there were a couple methods that you could do it with, and then I did it one method. So today I'm going to be doing it a different method. So assuming the algebraic method, which works for like more difficult problems, does take slightly longer, but in the harder problems, and my old strategy might not have come out as easily, because you probably couldn't tell. So yeah, the algebraic solution. Assume that the time that they meet is called t. Since the car starting from Boston started at 1 p.m., we go t minus 1 to know what time that the amount of time it took them for that one car to meet. And then you multiply by the speed it was going at, which was 50 mph. So this is going to be able to calculate, this is going to be equivalent to the distance that they have traveled. Because this is the time and this is the speed, so it equals the distance. So taking that, we can add to the second one as well. So the New York car, since this is also t, minus 1.5 because it's 130, multiplied by 40 has to equal 295. So now that we have an equation set out, we can solve it in order to calculate t, which is the time that they meet, which is also what the question is asking. So, taking that in mind, so 50t minus 50 plus 40t using the distributive property minus 6t has to be equivalent to 295. Taking that, combine the like term, so 90t minus 110 is equivalent to 295. Now we just do some simple algebraic calculations. 90t is equivalent to, when you move the 110 to the other side, you add it, plus 10, which is 305, plus 100, which is 405. So t is equivalent to 405 over 90. You divide top and bottom by 5. So on the bottom, you get 18. On the top, you get 81. Divide by 9, so 2, 9. So 9 over 2 is also equivalent to 4 1/2, which is, in this time case, also equivalent to 4:30 p.m. in specific, because they both left at p.m. and they're not going to drive until a.m. So yeah, slightly longer, but also would be more reliable on harder problems. Moving on to problem number 2. Megan has 3 candles of the same length to provide light, which for some reason, candle A burns for exactly 72 minutes, but candle B burns twice as fast as candle A because apparently the wax quality just isn't the same, man. Candle C burns 3 times as fast as candle B. What is the greatest total number of minutes that all 3 candles can provide? So, this one is relatively straightforward. If you are trying to see the greatest total number of minutes that all candles can provide, it's one after the other. So once one candle burns out, then you light the next candle to not waste wax, because you don't need that much light. Anyway, so since candle A burns for 72 minutes, candle B burns twice as fast as candle A, which is half of candle A, which is also 36. And candle C burns 3 times as fast as candle B, which is 1/3 of 36, which is 12. Which would equal our answer because, like I said, we're going to light them one after the other to provide the greatest amount of light. The wax quality just on the second two candles, they just suck apparently. Megan will know not to buy from them ever again. So if we add this is 108, 120, 120 minutes, 120 minutes of light, which is also 2 hours, which is actually considerably not bad. But if you had more of the good quality candles, you could stay in the light for longer. Anyway, yeah. That's the end of this video. I hope you guys enjoyed, and I hope you guys learned something new, and I will see you all on the next one. Ta-ta!